Number 10. Photons of infrared radiation are responsible for much of the warmth we feel when holding our hands before a fire. These photons will also warm other objects. How many infrared photons with the wavelength of 1.5 times 10 to the negative 6 meters must be absorbed by the water to warm a cup of water, which is 175 grams, from 25 degrees Celsius to 40 degrees Celsius? Okay, the first thing I want to say is you might be saying, what? And I understand. I totally understand, especially if you're taking chemistry atoms first instead of the other chemistry textbook in your OpenStax. The thing is that in the other textbook, in the chemistry textbook, just the chemistry textbook, they taught thermochemistry before they introduced electronic structure. In this Adam's First textbook, they teach electronic structure before they teach thermo, and I think this question kind of got slipped in. So you guys might not understand how to do this one because you weren't taught thermal yet. But have no fear, Christina is here. So the thing is that it says, we have a cup of water and it's going to warm the cup, right? So if something gets hot and you're warming something, this is all part of thermochemistry. So thermochemistry will be taught to you guys in a later chapter, but in order to do this problem, you have to know basically the number one equation that's found in the thermochemistry chapter. And I'm just going to give it to you guys, all right? The equation is Q equals mc delta T. Q is the amount of heat energy used to heat something up, but still it's a unit for energy. So in this case, it's not the E that we've been seeing, it's the Q. But still, this unit is going to be in joules. M stands for mass. And they told us that the cup of water was 175 grams. So this would be the 175 grams. That's a mass. C, and once we get to the thermochemistry, I'll see what letter they use. Sometimes they may use S, sometimes they use C. But just for now, let's just say C is the specific heat of an element or a compound. Now for water, this one is the only one that they want you to memorize. They'll tell you all the other specific heats for all the other different elements. But for water, for some reason, they want you to memorize that number. And that's why it's not given here. For water, it's 4.184. Grams per, joules per gram times Celsius. And then delta T is the change in temp. And for this formula, it will be final temp minus initial. A change is always final minus initial. And since the specific heat is in units of Celsius, we don't have to convert it to Kelvin. So this would just be the final Celsius minus the initial Celsius. All right, so what did they give us? Well, what did they give us, right? They told us that we had a mass, right, 175 grams, and they gave us these two temperatures. So it's from 25 to 40, so this is the initial and this is the final. So I can use this formula to solve for my heat energy that will come about in this problem. So if I say Q equals mc delta T, we're trying to find out how much energy is required to, make this hot, heat this up. So 175 times the specific heat of water, which is 4.184, times final temp minus initial. So it would be 40 degrees Celsius minus 25 degrees Celsius. Now, if you plug all that into the calculator, just like that, 175 times 4.184 times 40 minus 25, or if you want to do 40 minus 25 first and then calculate, it's fine with me. You'll get the same answer. So you get 10983. So 10,983 joules. Okay. I'm not really going to worry about sig figs here. If you want to do sig figs, this would roughly be 1.1 0 times 10 to the 4. But I'm just going to leave it as this. All right. So this is how much heat energy is needed to heat up this cup, right? So that's the heating up energy. Now, I'm going to put a divider here because we could also find the energy per photon, right? They gave us a wavelength, so we could find out an energy per 1 photon. So here, wavelength is equal to 1.5 times 10 to the negative 6 meters. And from there, we should know a formula that goes from wavelength to energy, and that's this formula, right? Actually, I'll write it down here. Energy equals hc over wavelength. We've seen this a couple of times in this chapter already. H is a constant number, right? H is Planck's constant, 6.626 times 10 to the negative 34th joules per second. And C is also a constant number, 2.998 times 10 to the 8th meters per second. So those are constants. You're just going to plug those right in. So energy equals 6.626 times 10 to the negative 34th times 2.998 times 10 to the 8th. I'm running out of room. Sorry about that, guys. Over the wavelength. It's already in meters, so we're good to go. 1.5 times 10 to the 6th. So let's do that. So 6.626 times 10 to the negative 34th times 2.998 times 10 to the 8th divided by 1.5 times 10 to the negative 6th is, we'll say energy equals 1.3 times 10 to the negative 19th joules. Okay, and remember, this, when you're dealing with wavelength, this is per 1 photon. Now, they want to find out how many photons. So, essentially, we want to get the photons in the numerator, right? So if we have 1.3 times 10 to the negative 19th joules per photon, per 1 photon, all we have to do is flip this, right? Because then the photons will be on the top. So 1 photon over 1.3 times 10 to the negative 19th joules. Now we just want to know, the question was how many infrared photons? So we just want photons to be there, but we want to cancel out the joules, right? So did we find something else that told us how many joules there were? Oh yeah, this one, right? So if I just multiply by 109.83 joules, what happens to joules? Oh, they cancel. And I'm left with how many photons this will bring us. And that's how we do it. So 109.83 divided by the answer you got, 1.3 times 10 to the negative 19th. And I get roughly 8.3. So 8.3 times 10 to the 22nd photons. And that's how you do it. So I'll just put it over here. So how many infrared photons? 8.3 times 10 to the 22nd photons. That's how many photons it would take. So this one was a little complicated. I understand, guys. It's just because we didn't learn thermochemistry. So we just had to do a new formula. But then once we got it, you just put the two together and you get your answer. All right, guys. Thank you so much. Let me know in the comments if this worked out for you. Like this, if it helped you out. And if you want, click subscribe. That'd be cool. Thank you so much. I'll see you guys in the next question. Have an awesome day.